Hello everyone, this is Kishore. Now I am explaining a video lecture on turbine. What is meant by turbine? So before going into the topic of turbine, let us see what is meant by hydraulic machines. Hydraulic machine means the machines which converts either hydraulic energy. Hydraulic energy means energy processed by water into mechanical energy, or mechanical energy into hydraulic energy, are called hydraulic machines. In the hydraulic machines, turbine is one type and another one is pump. Next, in this image you can see it is a hydroelectric power plant. One example, it is a Sri Salem power project. In this we can the power generation can be done with by a turbine. So that's why we need to study what is meant by turbine and the types of turbines. Let us see. So you can see the different images of the hydro power plants where we can see the applications of the turbine. Here it is in Nagarjuna Sagar power project. It is also is image of Sri Salem power project. This is another image of the hydraulic power plant. So it is a working principle. You can see in this image. It is a working principle of this turbine is Kaplan turbine. You can see this here. The water comes from the reservoir. In the coming slides, I will explain briefly. So here let us see what I mean by hydraulic measurements. It is a machine which converts hydraulic energy into mechanical energy, or called turbines. So in this image you can see here the water coming from a nozzle. It strikes the impeller. It is a example for the Pelton turbine. On the circumference of bucket, here the bucket will rotate by the striking of jet. So the this wheel is connected to the generator. Then by rotation of this wheel, it is coupled to a generator. Then we can produce the electricity. In the next slide you can see there is a sectional view of inside of a hydroelectric power plant. You can see here from the reservoir the water comes from to the here control gate, and then through the penstock the water impinges onto the turbine. So this is a turbine of Francis turbine. The water coming from the penstock will strike the blades in the Francis turbine. Then it will rotate. It is coupled to a generator. There you can produce the electricity, and then the used water from the turbine will fall into the tail race, and then we can send it to this tail race. So the power produced in the generator we can now send into the transformer from the transformer. So the transformer in the powerhouse, from the powerhouse the generator power can be transferred through power station through power lines. You can see in this image. And also you have another image of the hydraulic power plant. So there is a schematic layout of hydraulic power plant. So next we will see the classification of turbines. So according to type of energy inlet, we can classify the turbine as impulse turbine and then reaction turbine. And another classification is according to the direction of flow through runner, that is tangential flow turbine, radial flow turbine, axial flow turbine, and then mixed flow turbine. And then according to the head at the inlet of the turbine, we can classify as high head turbine, medium head turbine, and then low head turbine. According to the specific of the turbine, we can divide, that is low specific turbine, medium specific turbine, high specific turbine. According to the name of the inventor, that is Pelton turbine, Francis turbine, and then Kaplan turbine. First, in this image you can see the schematic diagrams of the Francis turbine, Kaplan, and then Pelton turbine. Now we will see one by one. In the Pelton, you can see this animation of the Pelton turbine. It consists of a nozzle and then a casing, and then a turbine. It is coupled to a generator. There you can see it is a power. And then in this nozzle, you can see the wheel is in the penstock. Will provide a wheel and then sphere. Thus, what is the function of the sphere means it controls the flow of water from the nozzle, and then the water from this nozzle, the water from this nozzle or jet of water strike the buckets on the. So this is a Pelton wheel. So you can see here in this image the water coming from the penstock, it will strikes the vanes on the runner. So if the water strikes the tangentially, so the vanes on the runner will rotate. So by rotating this here, it is this runner shaft is coupled to a generator. There you can produce a wheel. So here what is purpose of casing means casing can be used for the protection of the turbine. Next, so this is the shape of the bucket. That is a double splitter. You can see in this image double splitter, and then you can see the derivation of what is meant by reflection angle and then angle of deflection. So So there are another term, we'll explain the next slide. So next come to the Kaplan turbine. Kaplan turbine means it is named according to its inventor. So you can see the Kaplan turbine here. So it is also having wicket and then blades. So most probably you can see this image. So here you can explain. So Kaplan turbine having as a large shaft, and then it is having a conical end that is called hub, and then to the hub will provide the vanes, and then here this turbine comes under the axial flow turbine. So you can see here axial flow turbine. Main components of the Kaplan turbine are will provide the guide vanes for the flow of the water. The water coming from this, it will strike the, it will comes axial flow to the axis of the turbine. You can see here shaft of the turbine here. So the water flow is parallel to the axis. That means we can say it is a axial flow turbine. So you can I'll explain in the next slide. Next you can so this image comes for the Francis turbine. Francis turbine, you can see here. I'll show the video.
Property of the client GDF.
You can see here the water striking that Francis turbine. So the Francis turbine coupled to a generator. There you can produce the electricity. So from the transformer, the electricity can be transferred through transmission lines to powerhouse.
Turbine requires large turbines are low, can be calculated, used as water behind the dam. Dock is water reaching to the Francis turbine. Relatively short period of time.
So thank you everyone.